I'm Anil Kumar. In this video, I'm going to discuss very interesting series. We actually refer to them as triangular numbers, tetrahedral numbers, and pentagonal numbers. Now I have solution of these at different levels in this particular video. I'm going to start from a very simple way of finding the numbers in this particular sequence. So we'll start with methods learned in middle school, and so middle school students can also understand how do we find the 10th term. To find the 100th term, we'll develop a formula. For that, you may need some skills which you learn in high school. Okay, so in part 2, for each one of them, I'll take up how to form the general formula and get to the 100th term. So I hope all students will enjoy this series. Let's begin with understanding the triangular numbers. Here they are 1, 3, 6, 10, 15, 21, 28. Now these numbers are formed when you start making triangles. So you start with one number, then you can make one triangle, and if you increase, then these number of dots which form equilateral triangles like this, you can get all the series, right? That is how you create it. Then we have tetrahedral numbers. Tetrahedral is a shape. It is a three-dimensional shape. It's like something on the top which is being connected to other elements on a plane, kind of like this. So basically, let us say on the paper we have these three items and each one of them is being connected from top like this. This shape, three-dimensional shape, is called tetrahedral. Now it could be extended, right? So you could have a bigger triangle here. So you could have a bigger triangle kind of here. Do you understand? Kind of like this. And I mean, I should have made much bigger so that it comes here and then builds on, kind of. Or at times we also think it like this, that you have oranges placed on like this. Let's say we place here, let me put, let's say 6 oranges, right? So let's say these are the 6 oranges. Then you find that there are gaps in between where some other can sit, especially these 3 points. Is that okay? So we have 3 oranges placed on top of it, correct? So 6 plus 3 is 9, and then on top of that, there's a gap where you could. So you have a shape, three-dimensional shape, which gives rise to tetrahedral patterns. So in this case, you found there are 10 oranges, right? So 1 start with, and then 4, and then 10, and so on, correct? So you can extend this series. Then we have pentagonal numbers, which simply just make pentagons, just as we made the triangular series, as shown here. As you make bigger and bigger pentagons, you can count these number of dots and get a series. So that is how you can generate it. It's a very interesting exercise first to even get to these numbers, right? So I'll encourage you to actually draw these pentagons and find out these numbers, correct? Now let's move on and see how to find the 10th number in all these series, right? So let's do the 10th number thing. Begin with triangular numbers. So I have shown here 3 patterns. The first one starts with 1 dot, then a triangle with 3, and then another one with 6, then again with 10. And you can always extend, as I'm trying to show here. So you just extend and draw a line parallel to this to get to the next one, right? So you get an idea. So if you kind of continue with this series, you get more dots, and you can count, and then you get the next one. So that is how it could be expanded. So it's very easy to do it. So first exercise is just get to these numbers, and I hope the middle school students will really love doing all this. And once you get your series, then we have to now find what is the 10th number in this series, correct? So we already have first, second, third, fourth, 5th, 6th, 7th. So we need 8, 9, and 10. So how do we get that? Now this method of getting the 10th number is common to all the series which we'll be discussing here, right? So we call it difference method. So we'll have to find the difference. You need to find difference. So first difference, we call this as the first difference. So these are technical words which I'm using, but you know what it is. It is 3 minus 1. So what is 3 minus 1? This is what you have to write, right? So 3 minus 1 is 2, correct? Then you do the same thing for the next two terms. What is 6 take away 3? 6 take away 3 is 3. And then do 10 take away 6, 15 take away 10, 21 take away 15, 28 take away 10. Like this, right? So let's see the pattern. So 10 take away 6 is 4, 15 take away 10 is 5, 21 take away this is 6, and then you get 7. Of course, next number, what should it be? Well, I think you have to add 8 now, right? So what we need to do here is to 7, we should add 8 to get the next number. So I hope that gives you the idea of how we can build on this triangular series. Correct? So add 8 to 28. So 8 plus 8 is 16 and 1. That gives you 36. And then what? Then you have to add 9 and then you have to add 10. So then you add 9 to 36 and what you get is 45. And then you add 10 and you get 55. Correct? So we find that the 10th number should be 55. Is that okay? So have a good look at it. So simple to find the 10th number. From the first difference, we found a pattern, and that is increasing numbers by 1. And if you keep on adding, you get your series. You got the idea, correct? Now let's look into the tetrahedral number series. And now you know, first how to create it. So kind of, as I said, it's a three-dimensional figure. So you have one dot here. That means one orange is sitting here. Then you place 3 and 1 on top. And then you place 6, 3 on top and 1 over them, right? So keep on adding oranges like this. And you can count them to make the series. So here we have a series. So what are we going to do to find the 10th term? Well, to find the 10th term, we'll find the difference, right? So we'll find the difference. Let's see what is the difference. So 4 minus 1, 10 minus 4, 20 minus 10. So we have to do this difference. So I hope you get what I'm trying to see here, right? So 4 minus 1 is 3 and 10 minus 4 is 6 and then 20 minus 10 is 10 and this is 15 and 56 minus this, 6 take away 1 is 1 and 5 is 21 and then 84 minus this, so 4 and 4 is 8, I borrowed 1, so it's 28 and likewise the series is going. Now how are we adding these numbers? Is kind of tricky. So what I will do here is this time we call this as the first difference, right? So first difference is very complicated to work with. Well, let's find the second difference now. So second time we will do the same operation and see now what happens. So we'll do now 3 minus this, this minus this, this minus this, this minus this, and so on. So let's see what do we get now. So 6 minus 3 is 3 and then 10 minus 6 is 4 and this is 5 and this is 6 and this is 7. We do get a pattern. Do you see that? So at times if you don't see a pattern in the first difference, you can continue that, right? And then it'll be simpler. So now we'll do reverse calculation. So now we'll work reverse order. Reverse order to get our numbers. So this is very interesting. That means what? That means I'm going to add 8. I'm going to add 8 and get the number here. And then again, I will add that number and get this number to the next time, right? So 8 plus 28 is what? 8 and 8 is 16, 6 and 1. So we get 36 here. 36, good. So next number will be what? I have to add 36 and 84. So when I add 36 and 84, 6 plus 4 is 10 and 1. So it is 12. 4 and 8, 12. Okay, so we get 12 here. So 120. So 1, 2, 3, 4, 5, 6, 7, 8. We have to go 9 and 10. 9 and 10. Is it okay? Now this time, again, what we are going to do? We are going to add 9 this time, get this term, then we'll add 10. You get it, right? And I can actually leave this for you to do. And then we get this term, and then we get that term, correct? So let's do it. So when you add 9 to 36, it becomes what? It becomes 45. And when you add 45 to 120, so it becomes 165. Is that okay? Now that's next time for the 10th term, 45 plus 10 is 55. And when I add 55 to 165, 5 and 5 is 10, 0, 1. 7 and 5 is 12, 2 and 1, 220. So we say the 10th term is 220 for us. Correct? So we got the 10th term of the tetrahedral numbers. Now let's talk about the pentagonal numbers. How do we create them? Well, start with one dot, make a pentagon, put dots on each corner, all vertex. You get a pentagon, and then you count them. You get 5. And then increase the size to double and see how many pentagons can you get inside. You get one inside, one outside, count the number of dots. And that gives you 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To get the next one, we have to draw 3 times. So we get 1, 2. So instead of getting 3, you get 4. So we got 3 segments here. And then you increase it. You get an idea. And then when you count, you will get 35. So that is how you create this series. So that is first exercise. We already have few of them. So we have first pattern, second, third, fourth, fifth, sixth, seventh. We want to find the numbers in 10th pattern. That is the exercise, right? In part 1. So 7, then we have to 8, 9, and 10. How do we figure it out? Well, the best way is to find the differences, right? So we find the differences and then we figure it out. Finding differences, as you learned, is 5 minus 1, 12 minus 5, 22 minus 10, and so on, correct? So you can get the next number once you know the pattern, correct? So let's figure out the differences first. So in our case, the differences are 5 minus 1 is 4, and 12 minus 5 is 7, and then we get 10, and here we get 13. What do you observe? Whenever you do such things, see the pattern. Now the pattern, as you can see, is they are increasing by 3. Do you see that? They are increasing by 3. So next number should be 16. If I add 16 to 35, I get 51, correct? And then we should have 19. 19 plus 51 is 70. Or you could say 70 minus 51 was 19. But we have to get the 8th term. How do we get? Well, since this difference is increasing by 3, difference between that and 70 should be 19 plus 3, and which is 22, right? So it is 22. So once I add 22 to 70, what do I get? I get 92 as my number, correct? Now next difference should be 22 plus 3, and then that number plus 3. So 22 plus 3 is 25, and 25 plus 3 is 28. So that is the way differences are going to increase. And if we put this number, that is to say, if I add 25 and 92, what do I get? 2 plus 5 is 7, 9 plus 2 is 11, 11, 7. And now we have to add 28 to 117. So we get 8 plus 7 is 15, 5 and 1, 4, 145. So the 10th pattern will have 145 dots in it, right? So you get an idea. So I hope till now the exercise was very simple. So even a middle school student could have done it. Now from here, the question is, how do we find the numbers in 100th pattern? You can't go on and on like this. Well, you can, of course. It takes much longer. So we need to find a pattern rule, right? So now we are coming to pattern rule. So I'm going to use some mathematical tools which you have learned in high school, right? So to find the pattern rule. But we'll keep our process simple, and that is, we call it finite difference. So by finding these differences, we'll come to know how the numbers in these patterns are related with a formula. So we are basically developing a formula, right? So what we will do now is, we'll go one more step. As seen here, we'll find the second difference. So this is what I did was the first difference. Okay, so let me write down the term first difference. Now we'll find the second difference. We have to continue this process till the difference is a constant number, right? So let's do it. So what we have here is, we have to do 7 minus 4, 10 minus 7, 13 minus 10, and so on. This is what we have to do. Now what is 7 minus 4? It is 3. You know it is increasing by 3. So all these differences are constant and they are equal to 3, right? So that is what it is. So now we can get our formula. The formula is simple. Once we get to a finite difference which is constant, right? So what we say is, second difference is constant, right? So second difference is constant. It means that the expression which can represent this is like a polynomial of degree 2. So that means we are looking for a polynomial of degree 2. And what is that? That is a quadratic function, right? So we could write this as y equals to ax squared plus bx plus c. Do you get the idea, right? So y equals to ax squared plus bx plus c is a polynomial of degree 2, which you also call quadratic equation, right? Since the finite difference, which is second one, is constant. Is it okay? So now we will develop the formula. And as you know, or as you might know, this second difference is also related with a. How is it related? A is equal to, let me write down, a is equal to the finite difference, whatever is a constant finite difference, which is the second one for us, divided by, if the second one is constant, then it is divided by 2 times 1. If the third is constant, then we divide by 3 times 2 times 1, right? So in this particular case, since we know that second finite difference is 3, which is constant, so we will divide 3 by 2 times 1, which is 2. So that gives you the value of a, right? So we know a now. So we can say the equation is y equals to 3 over 2 x squared plus bx plus c. Now, how do we find b and c? That's a big deal. How do we find b and c? To find b and c, we have to use at least 2 numbers, right? Rather 2 equations, correct? So what we will do is, we will use these numbers. First pattern, we have got 1 number of dots. The second pattern, 2, we have 5 number of dots. So using these 2, from our patterns, we can find the value of b and c, right? So we get 2 more equations. To solve for 2 variables, 2 unknowns, we need 2 more equations, correct? So if I put 1, 1, that means this I'll treat as x, right? So this will be x and this will be y for me now onwards, right? So we get 2 more equations. So if I put 1 here and 1 for x, I get 1 equals to 3 over 2 plus b plus c. Do you see that? So I get 1 more equation. Now if I put 2 and 5, that is 2 for x and 5 for y. I get 5 equals to 3 over 2 times 2 for x. So 2 square is 4, right? 2 square is 4 plus b times x, that means 2b, and the constant c. Is it okay? So we get 2 equations by placing the numbers 1, 1 and 2, 5. So we place the number, we'll call this as equation 1, this as equation 2. In this equation, for x we placed 1, for y we placed 1, right? And here for x we placed 2 and for y we placed 5. And we got our equation, correct? Now from these equations, we can actually find the values for b and c. Let's see how. So if I do equation number 2, take away equation number 1 as you do simultaneous equations, what do you get? 5 minus 1 is 4, so I get 4 here, equals to 3 by 2, 4 minus 1, that means 3, right? So I've purposely not broken this up. So I'm writing 4 minus 1. Do you see that? 4 minus 1. And here we have 2b minus b is just number b, and c minus c is 0. Correct? So what do I get? I get the value of b. This is 4 on this side. And then I have here, let me rewrite this as 3 over 4 times 3 plus b, which is 9 over 4. So I'll do 4 minus 9 over 4 to get the value of b. So 4 times 3 over 2, I made it, this is 3 over 2, right? So let me make this correction, 3 over 2. So this is 9 over 2, I'm sorry. 9 over 2, right? It is 3 over 2. By mistake, I wrote 4. So 2 times 4 is 8. 8 minus 9 is minus 1. So I get minus 1 over 2, right? So I get minus 1 over 2 is the value of b. So I know what b is now, correct? Once I know what b is, I can substitute this value of b and find what c is, correct? Let's do it. So we'll use the first equation, which is 1 equals to 3 over 2 plus b. Instead of b, I'm writing minus half. And then we have plus c, right? So I'm substituting the value of b. Let me call this as my equation number 3. So we are substituting 3 in 1, equation number 1. Is it okay? So from here you can calculate the value of c. So let's do it. So 1 equals to, so 3 over 2 minus half it is. 3 over 2 minus half plus c, which is 1 equals to, that is 1, right? 1 plus c. And that tells you that c has to be 0 for this equation to be true. And finally, we do get our equation, and which is y equals to the value of a, which is 3 over 2, right? 3 over 2 x squared, and the value of b, which is minus half x. That becomes your formula. You can always take half x common. So you could write this as y equals to half of x common, right? And if you take that, you get 3 here, right? So 3x minus 1. So that becomes your general formula for pentagonal numbers. Do you see that formula? That is how you derive it. Now, if you have to find the 100th term, put x as 100 and calculate your answer. Correct? So that is so simple. So figure out the pattern number, the numbers in any pattern using this particular formula, right? So it is half of 100, right? And then you have 3 times x minus 1, which is 300 minus 1, right? So 50 times all that gives you the answer. Is it okay? So if I do, it is easier to do 50 times 300. You can use the calculator and find the answer. Let's do it once, and then I'll show you without calculator also. Is it okay? So half of 100 is 50. So we have 50 times 299, correct? To get the number, which is very big number, 14950, correct? But let me show you how you do without calculator. Very important to understand. Let's do that also, right? So we could write this as, let me use this little space, or here I'll do. Okay, so I'll say y is equal to, I'm using this space to find the number and to show you how. So it is 50 divided by 2 is, 100 divided by 2 is 50 times 300 minus 1. So don't make it 299. First multiply by 50, right? So you get 3 zeros, 1, 2, 3. 5 times 3 is 15. Is it okay? So you get 15,000. Now you take away 50 times 1, which is 50. So once you take 50 out of 15,000, what you get is 14,950. So that is your answer. Is it okay? So 100th pattern will have 14,950 dots. Perfect. That is how you do it. Now, I think I can leave you with this. You can adopt this method and find out the 100th term for the triangular numbers and for tetrahedral numbers. Correct? Okay. Now let us explore how do we get a general formula for triangular numbers and how do we find the 100th term. Right, so that is the exercise for us. So we'll do exactly similar to what we did for the pentagonal numbers, right? So the idea is find out the difference which is constant. So we are actually looking for a constant difference, right? So first difference is not constant, it is increasing by 1, and that suggests that the second difference is going to be constant. Is it okay? Now how much is it? So if I do the difference, that is, if I do consecutive numbers difference, what do I get? Clearly, 3 minus 2 is 1, 4 minus 3 is 1. So 1 is the finite constant difference. Since it is the second finite constant difference, we are going to use the quadratic equation y equals to ax squared plus bx plus c to represent our formula. Correct? And as you learned in the previous exercise, the value of a clearly is the finite difference, which is 1 divided by 2. So we know the value of a. Since we know a, we can write down this equation as y equals to half of x squared plus bx plus c. Now here we have two unknowns, right? B and c. To find these unknowns, we need to consider 2 points. So we'll consider 2 points. Pattern number 1 has 1 number of items. Pattern number 2 has 3 dots, right? So we are going to use these two to form 2 equations, correct? So this exercise is going to really help you. What we learned last time, it can be implemented as such, correct? So now we get 2 equations, 1, 1. So 1 for x and 1 for y. So it becomes 1 equals to half plus, this is times 1, this is times 1 means just b, plus c. But if I substitute 2 and 3, 3 for y, right, 3 for y, and 2 for x, 2 square is 4, so let me do half times 4, plus 2 times b, plus c. Is it okay? So we get 2 equations, just as we got them last time for pentagonal numbers. Now what should I do? I should do the difference, right? So now I will do the difference, which is 2 minus 1, just to keep them positive, right? So once I do 2 minus 1, 3 minus 1, you know, is 2. And here we have half, half. 4 minus 1 is 3. So I get 3 over 2. Perfect. See, working with fractions is not difficult. So that is what I want to show you. And 2b minus b is just b. And c minus c is 0. So we are left with b plus 3 by 2 equals to 2. So what is b now? Let's find it. And then we'll find what c is. So in this equation, we have 2. And then we'll take 3 over 2 on the left side. And then we say this is b. So 2 times 2 is 4. 4 minus 3 divided by 2 is b. Or we can say b is the number half, right? 4 minus 3 is 1. Once we know what b is, we can find what c is, correct? So in our equation number 1, this equation, let me rewrite the equation. We have 1 equals to half plus b plus c. Now we know b is half. I'll add half for b, right? So we can write this as 1 equals to half plus c. Now that is 1 equals to 1 plus c, and that means c should be 0, correct? So we get c equals to 0. Now if c is 0, b is half, what is this equation? Now we wanted to find what is y equals to ax squared plus bx plus c. We know this is half, this is 1, and this is half, right? And therefore, substituting their values, I get the value of a is half for us, so we get half, x squared, b is half for us, so we get plus half of x. Now we can take half x common, so we get y equals to half x common, and what do we get here? We get x plus 1. Do you see that? So that becomes the general formula for triangular numbers. So this is the general formula for triangular numbers, right? Now it is very interesting to know that this number is also representing the sum of natural numbers, right? So there's a very interesting series before you, and let's first find the 100th number and then we'll do the needful. So y equals to half of, replace x with 100, and we have 100 plus 1, right? So that means 50 times 100 plus 1. So I'll multiply with 50 as you saw last time, giving me 50, 100, 5000 plus 50, right? And therefore the answer is 50-50, right? So this sum is 50-50, correct? You could use the calculator also to find this sum, right? So 100 times 101 divided by 2 and 50-50, that is correct. So that is how you get your total. So 100th term is 50-50 as you have seen here. Now let me tell you something more about it. That is, this is actually sum of natural numbers formula, right? Now you could see that this series, when we say 2, 3, when we say 1, 3, 6, 10, 11, 15, 21 and so on, you could also write this as 1 and 3 is like, let me write here, let me reproduce this series as sum of natural numbers. You will understand what I'm trying to say. Series is, let's look at this series here. So let me highlight this first and then we'll rewrite it as sum of natural numbers. Okay, so I'm going to write 1 as just the number 1. Let me write it in this box here. First few terms, right? So 1 is just 1, okay. Now 3 could be written as 1 plus 2. 6 could be written as 1 plus 2 plus 3. And 10 could be written as 1 plus 2 plus 3 plus 4. And 15 can be written as 10 plus 5 plus 6, right? So it is sum of natural number 1 plus 2 plus 3 plus 4, like this. Do you see that? So sum of natural number formula is also the same, which is n times n plus 1 divided by 2. So triangular numbers represent sum of natural numbers also. So I hope you find it very interesting. And now we will see how to find the 100th term in tetrahedral numbers. Now let us develop the formula for tetrahedral numbers. Now this is going to be a bit complicated since we land up in cubic equation. Now here grade 11 and 12 skills will be required to solve this question. So we are looking at tetrahedral numbers 1, 4, 10, 20, 35, 56. We just saw that the first difference is 3, 6, 10, 15, 21. The second difference is not constant. It is 3, 4, 5, 6, 7, 8, 9 and so on. But the third difference is constant, correct? So if I continue now and if I find the difference, I do get the third difference as constant, which is 1, correct? So as you can see here that the difference is 1, which is constant, correct? Now that's the whole idea. Once we know that the third difference is constant, we know that the polynomial of degree 3, which is a cubic equation, right? So that means constant third difference means we're looking for y equals to ax cubed plus bx squared plus cx plus d to be the equation representing tetrahedral numbers 1, 4, 10, 20, 35 and so on. So now we have to work with finding 4 coefficients A, B, C and D. A is simple to find. We can say A is equals to the constant difference 1 divided by, since this is 3 times 2 times 1, which is 6, correct? So we get the value of A. I could write this as y equals to 1 over 6 x cubed plus bx squared plus cx plus d. To find 3 unknowns, which is B, C and D, I will have to take set of 3 numbers, correct? So in our pattern, what we see here is that the first pattern has 1, the second has 2, third has 3. So we'll take these 3 to work out, correct? So now we'll work with these three numbers to form three equations, 1 and 1, then we'll work with 2 and 4, and then 3 and 10. Using 1 and 1, I'll get the equation 1 for y, 1 for x. So we get 1 over 6 plus b plus c plus d. Is it okay? So 1 for x gives me this. If I use 2 and 4 for y, I get 4 equals 2. 2 cube is 8, so I'm writing 8 over 6 here. 2 square is 4, so I'm writing 4b. And 2 is 2, so we get plus 2c and plus d. Is it okay? So we get these two equations. For the third one, I'm going to use 3 and 10. So 3 and 10 means 10 will be the y value. We have 1 over 6 times 3 cube, which is 27. So we get 27 over 6. And then here 3 square is 9. So we get 9b, 3c plus d. Is it okay? So we get these three equations to work with. So we have one equation, second equation, and the third equation. Since my space is limited, I'm cutting down on steps, but I'm explaining you everything, right? Now let's eliminate. So if I take away equation 1 from 2, right, see here, then what do we get? In that case, I get my equation. Let me change the ink. 4 minus 1 is 3. And now I kept them in fractions. So we have the common denominator. 8 minus 1 is 7. So equals to 7 over 6. Now 4b minus b is 3b. Okay. 2c minus c is plus c. d minus d is 0. Now if I do the other two equations, right? So if I do the other two equations, 10 minus 4 is 6 equals 2. Now we have to do 27 minus 8, which is 19 for us. So we get 19 over 6. And 9 minus 4 is 5. So we get 5b. And 3 minus 2 is 1. So we get 1c. Correct? So we get these two equations. Now if I subtract one from the other, correct? So we'll call this as our equation number 4 and 5. And now I'm doing 5 minus 4, right? 5 minus 4 to get the next equation. Okay, so 6 minus 3 is 3. Now these fractions, I kept them as 6 in the denominator. Do you see that? 19 minus 7 is 12, so we get 12 over 6. Plus 5 minus 3 is 2, 2b. c minus c is 0. So do you see how neatly we are actually calculating and working with cubic equation, and that is the way it should be worked. Now you can find what b is. Now 12 over 6 is indeed 2, right? So we have 3 equals to, let me write here, 2 plus 2b. And so when we take away 2 from here, so we get 3 minus 2 equals to 2b. And we can write down what b is. B is half, correct? So that gives you the value of b as equals to half. Perfect. So we get the value of b as half. To find c, we can use one of our equations, correct? So I'll substitute b as half in equation number 1. Is that okay? And then we are going to find the value of c. And then we'll move upwards and find d also, correct? Okay, so using this particular equation, I should use one of these actually first, not that one for c. So not that one. I have to use some else, only one of these, right? So we'll use one of these. So we'll use this equation. So we are going to use the equation number 5 and 6, the value of b. So we know b is equals to half, and we'll substitute this value in equation 4. In equation 4, right? Okay, so let's do it. So if I substitute, we'll get 3 equals to, let me write down, 3 equals to 7 over 6 plus 3 times b is half, right? Plus c. This is what we get, right? So we can combine these two terms and then take from here, or let me write this like this. 3 minus 7 over 6 minus 3 over 2 is equal to C. Perfect. So that gives you the value of C as, let's take common denominator 6. So we get 6 times 3 as 18 minus 7, and 3 times 3 as 9 is the value of C. Correct? So 18, 9 and 7 is 16, and so we get 2 over 9 and 7 is 16, so we get 2 over 6, or 1 over 3. Is it okay? So now we get the value of C as 1 over 3. We found the value of B as half, and we already found the value of A from the constant difference, which was 1 over 6. Correct? Now to find D, I can use my equation number 1. So using equation number 1, which is 1 equals to 1 over 6, the value of B is half for us. We'll do plus half. The value of C is 1 over 3, right? And then we need to find what D is. So we can add all this. So we get 1 equals to, taking 6 as the common denominator, we get 1 plus, this becomes 3 plus 2 plus D. And that is just 1, right? 6 over 6, which is 1. That means D is equal to 0, right? So we get D as 0. Finally, we can substitute the values of A, B, and C here, get the equation. So we get Y equals to, A is 1 over 6, x cubed, plus B is half, right there, x squared, plus C is 1 over 3, so 1 over 3 x. Do you see that? So that is how you can get your formula, right? This can be rearranged. Let me do that part also. X is common, and 1 over 6 we can take as common. So we can write this as 1 over 6x, and what do we get here is x squared. Since we took 1 over 6 common, this will be 3 times. So we get 3 times x, and here it will be 2 times, right? So plus 2. So this is a quadratic equation. We are looking for product of 2 and sum of 3. So this could be factored, and we're running out of space. Anyway, let me write here, then I'll rewrite. 2 times 1, right? So we get x plus 2 times x plus 1. So that becomes the formula, correct? So let me rewrite this formula here. So we get the value of y as equal to 1 over 6x times, we'll write x plus 1 times x plus 2. Do you get it? Perfect. So that is the formula you can always use to find the numbers in any pattern when we are talking about tetrahedral numbers. Now what is the 100th term? Not very difficult. So what you do here is you can replace x with 100. So get 1 over 6 times 100 times 101 times 102 and get the answer, right? So that is how you could actually get it. So we get 100 times 101 times 102 divided by 6 as equal to that big number, right? So 171,700. So we get 171,700 as our answer. Do you see that? But I hope you understand and appreciate how using finite difference and some concepts from polynomials, we could easily find the pattern rule for nth term, and that helps us to find any number of terms. So I hope you find it interesting and useful. Feel free to share your comments and views. If you like and subscribe, that'd be great. Thank you and all the best.